times, people have wanted to communicate over long distances. Early methods include smoke signals, drums, reflecting sunlight, and even shouting!
Using wires was a big step forward. First of all, Morse code was used. The problem with this is that you had to learn the code. So, Alexander Graham Bell invented the phone.
Hello.
Hello, how are you?
Goodbye.
Goodbye. After the phone, that used optical fibres.
Optical fiber is a thin piece of glass light can pass through, like this. This is another example of optical fiber. And this one shows how the light reflects. This is called the law of reflection. This shows how the light reflects on the same angle. So this angle is the same as this angle.
This is how real optical fibre is made. They are pulled and stretched thin. Wait a minute. Okay, they are stretched thin and flexible so that it can receive phone calls easily. This is optical fibre. Each little thingamabob can send over 2,000 phone calls at any one time. Okay. This is a receiver and this is a radio. This is making noise, and when I plug this into here, the noise gets changed into light. Then that comes out there, and then once I plug in an optical fibre, it travels through the optical fibre, and then a receiver picks it up from miles away, and then we can hear it.
Wireless, like a radio, which sends an invisible wave from the receiver, no, transmitter to the receiver.
Go! Oh, it's Fuzzy's one.
You get different frequencies of waves. Radio waves have very high frequencies. Here are some low frequency waves look like. Here are what high frequency waves look like.
The different parts of a radio receiver are aerial. The aerial receives all of the radio signals and changes them into electrical signals. The tuner. A radio is able to receive radio waves from many different stations. To keep the signals separate, each station transmits radio waves at a different frequency. The tuner lets you select a particular radio station you want to receive. The decoder. There are two parts to receive signal. One part is required to allow the waves to travel large distances. This part is not needed when the signal has reached the radio. The other part is a bit that we need, called the audio wave. The decoder separates the two parts. The amplifier, the signal that is left after passing through the decoder, has very little energy. This signal has to be amplified. The amplifier increases the strength of the receiver's signal. It makes the energy of the received signal larger. To do this, the amplifier needs to be supplied with energy from a battery or power supply. Listening. The amplifier electrical signal must now be turned into sound energy so you can hear it. This requires a loudspeaker. The loudspeaker changes electricity energy into sound energy.
The main parts of the TV are detailed to my right, the left. Aerial. Picks up all the TV signals and changes them into electrical signals. The tuner. Picks out the frequency of the TV and selects the station you want. The decoder, vision, selects a signal from the waves. The amplifier, vision, makes a signal stronger. The TV tube, well, TV screen, sorry, turns the electrical signal into light. Decoder, audio. The decoder audio selects a signal from the waves. Amplifier audio makes a signal sound signal stronger. Loudspeaker turns the electrical signal into sound.
TV has three primary colours, which are the main colours: blue, red and green. When you mix red and green together, you get yellow, and when you mix red and blue together, you get pink, and when you mix red and green together, you get yellow. And when you mix all three colours together, you get white. These are the three main colours on our TV screen, which make the colours and the shapes of our TV.
Radio waves can send signals all around the world. We are using a light beam to imitate radio signals and a mirror to imitate the satellite. Radio waves travel in straight lines, so we use satellites to reflect them from one side of the world to the other. A geostationary satellite is a special satellite which revolves around with the world as it rotates, so it stays above the same point on the Earth's surface all the time.
One problem is that the satellite is so far away that the signal is very weak by the time it gets back to Earth. We can use a curved reflector or satellite dish to concentrate the signal onto a point to make it stronger. Again, we are using light to repeat the radio signals from the satellite.
Finally, we are using infrared or heat radiation to show how waves can be brought to a focal point with a curved reflector. The heat from the gauze above the Bunsen spreads in all directions. The first curved reflector turns it into a beam. The second reflector generates the heat onto a blank paper.